Prove the statement using the epsilon delta definition. And I would like to add that in here. So the precise definition of the limit is one way of saying it, or the epsilon delta definition is a different way of saying it. So we're either asked to use the precise definition of the limit to show, or we're asked to use the epsilon delta definition to show that the limit exists. One or the other. So in our problem, we're asked to prove the statement using the epsilon delta definition. Okay. So I start with a double equivalency. That's the first step. And then I write, for every epsilon positive, I will find the corresponding delta positive such that every time I pick, oops, I meant to re-zero. Every time I pick x, how far from what? Yes, which is, what is the a in our case?
10.
Very good. So x minus 10. Every time I pick x close to 10, but not further away than delta, within that interval, what will happen? This is not a double equivalency, but this is the implication symbol. So what will this imply? I pick x close to 10. It means that the corresponding f of x, what is the f of x? Please read the f of x for us. Minus. The f of x will be close to the limit. What is our limit?
-1.
Correct. But it's minus 5 in this case, so what do I write? Indeed. This is the distance between f of x and -5. What should it be? For sure, guaranteed.
Less than epsilon.
Less than epsilon. Awesome. Indeed, that's the answer. So one more time, for every epsilon greater than 0, I would find a delta around 10, such that when I pick a number close to 10, the f of x will be within 5 units, within delta epsilon units away from -5. Very good. First step. We start with this. 3 minus 4/5 plus 5 less than epsilon. What am I trying to find? So I should have written that first step, I want to find delta. So the definition says that for every epsilon, I can find the delta. Well, I have to find the delta. Yes, please.
Would you need to include the x for?
Oh, yes, of course. I'm sorry. Thank you. Thank you, Vanessa. And I'm not hungry. Just kidding. Okay, so first step, we simplify as much as possible. But before that, I want an answer. So because I need to find delta, I start with the function. I simplify, and I'll show you the next steps. But where is my target? What do I want to do? Where do I want to be? I start from here, simplify it, and what will I eventually want to see? I want to see that. That's my target. Whatever I do here, the left-hand side has to be that. And then the other side will be whatever it comes out to be. So I would do anything in my power to simplify step by step to have just that on the left-hand side. Because if I do, then it's very clear what is left will never have x in it, of course. Whatever is left will be delta. Good. So then I added 3 and 5. What else can I do here?
Plug in.
I cannot plug in, I cannot divide. Inside the absolute value, what will be my next step? What can I do with these two quantities? The only thing I can do.
Add
Exactly. And I need to find,
common denominator.
which is? Excellent. What do we have at the top? Negative 4x plus. Awesome. We're getting closer. Okay. At this stage, I need to present two properties of the absolute value to you. The absolute value of a product is the product of absolute values. And the absolute value of a ratio is the ratio of the absolute values. Let me also refresh your memory that the absolute value is not a grouping symbol. You cannot take anything out. You cannot bring anything in. You can't touch it. It's untouchable. So these are the only properties that we can use. So what do you think I'm going to continue with? Obviously at the top, because the bottom is kind of clear. What do you think I'm going to do at the top? Yes?
4.
Exactly. No, factor out negative 4. That's the only thing I can do. I cannot do anything else. Good. So careful. Is it clear that we're getting closer? Good. Now I have to use these properties. And I have to show them at this stage. So can anyone dictate the next step? Negative 4 times. Very good. Over. I can't. I have to. You can say, isn't that 5 true? But I have to show the step. By using the two properties, the absolute value of a product and the product of absolute values and the absolute value of a ratio. Are you with me? It's long because it's the first example. When we look at the second one, you'll see it's going to be much easier. Okay. What is now the absolute value of negative 4?
4.
What is the absolute value of 5?
5.
I only want to solve for x minus 10. What do I do to both sides to have x minus 10? Why? Why? One more time. This is what I am after. This. That will depend on epsilon. So what should I do to both sides to have just this on the left? Excellent. I'm done. Can anyone give us delta? So if I say epsilon is 1, it's huge. But let's say, for simplicity, if epsilon is 1, what will you say delta is for that particular epsilon? If I say epsilon is 0.1, what will you say the corresponding delta would be? 0.5 over 4. What if I say epsilon is 0.3? What is delta? 5 times 0.3 over 4. And I can go on forever. Why? Because the limit exists. In step 2, show that delta equals 5 epsilon over 4 works. I will not make you go in reverse. I will just ask you to write by reversing the above steps. That's all I care about, just this sentence. Why do I have to show this way? Because of the double equivalency symbol. From here, this. From here, this. Both sides. Yes, please. Yes. Any questions? Ready to look at another? Yes? Ready to work on another problem? Yes, please, Vanessa.
If that's step 2, like, is that finished, or do you
It's finished. That's finished. That's all. That's all I want you to do. You don't have to build this going backwards. I don't care for that. I'm fine with just this.
So just write that.
That's it. Yes. For step 2, the other direction, I'm fine if you just write this sentence. This tells me that you understand that the double equivalency means you have to show one way and you have to show the other way. But you don't have to really do it. I'm fine with just one direction. Show that delta equals 5 epsilon over 4 works, reversing the above steps. I'm fine. Okay, so I know this took a long time because I needed to explain and give you the idea of what's happening here. But you'll see the next problem should take much less. Okay, so let's say the same question. Let's say with limit. Okay, I picked problem 16 on the same page 117. Limit as x approaches 4 from either side from 2x minus 5. We don't need them to tell us what it is, and you'll tell me what it is. Very good. So the double equivalency, and please tell me how to start. For every epsilon greater than 0, we will find, or there exists, a corresponding delta awesome, such that every time we pick
a number between
x
minus 5, absolute value
x minus 4
of x minus 4,
less than
3.
very good. This will always imply, will guarantee that the distance between two x minus 5, the distance between 2x minus 5 and remember the function goes with this and x goes with 4, less than, good, that's it. So where do we start? In step 1, find delta. Where is the starting point? The absolute value of 2x, very good, less than epsilon. Let's stop for a moment and say, where is our target? Point the target to me. What do I do here to get that? No, I can't. Yes, because of the absolute value. But yes, eventually I will divide by 2, but not yet. I have to use the properties of absolute value first. What do we have? Very good. And now I have to use the property. The absolute value of a product is the product of absolute values. What do I write? The absolute value of 2, I have to write this step. I know you understand, but we have to write this step. What is the absolute value of 2? Because you are not allowed to multiply and divide in an absolute value. You cannot do that. You can only use these two properties. So now 2x minus 4 less than epsilon. Now I can divide by 2. The absolute value of x minus 4 less than epsilon over 2. Did we find delta? We are comparing this to this. So please compare. How much is delta? In step 2, show that delta equals epsilon over 2 works by reversing the above steps. That's all I need. So now if I say, let's say epsilon is 0.1, what would you say delta, corresponding delta would be?
0.1 over 2.
If I say 0.3, if I say 0.0005, you will always determine a corresponding delta, and because I can pick any epsilon I want, the limit exists. So it was not very straightforward. Maybe at the beginning that after the second example, I think most of us got it. What do you think? Okay. I know I only have 5 minutes left. I don't want to start a new section, so let's work on another problem. Yes, Vanessa?
Yeah, I was gonna ask if you do it.
Yes, yes. So let's look at another one. So let's say 17. So 17 on page 117. Limit x approaches -3 from 1 minus 4x. And I would like you for Thursday just do 2 problems. 41 on page 107. And from this section, 21 on page 117. Yes, 41 is 107 and 21 117. Just these 2 problems. Okay, can anyone give us the limit here? How much? Very good. So now then you will say this is equivalent to good. Yes, it must be positive, of course, such that every time we pick x, you understand why we write this. Because you can say it makes no sense. The absolute value is always greater than 0. But this indicates that I cannot have equal 0. That's all it means. The absolute value of? Excellent. Oh, well done. Every time I pick x close to -3, how close? So that the distance between x and -3 must be less than delta. Very good. This will guarantee absolute value 1 minus 4x. Awesome. Excellent. In absolute value, everything has to be less than. Good. Awesome. So then find delta. Where do I start in finding delta? Well done. So -4x minus 12 in absolute value less than epsilon. Good. Next step. Factor out. What am I factoring out? -4. So this is not cheating. But where's my target? What do I want on the left-hand side eventually? In absolute value. Good. So then what is left in parentheses? Good. Now I have to show the property. I cannot multiply, divide, simplify in any way an absolute value. I have to use the properties that I showed you. What will I write? Times. Very good. Less than epsilon. What is the absolute value of -4? Excellent. And I'm down to the very last step. So then the absolute value of x plus 3 is less than? All I have to do now is compare these 2. Please compare this with this and tell me what is delta. Why this works? Why can I find a relationship between epsilon and delta? Because the limit exists. Otherwise, I would not be able to for every epsilon. So number 2, reverse the steps from above to show that delta equals epsilon over 4 works. Any